So we're currently learning about waves and understanding that there's a relationship between the amplitude of a wave and the frequency of a wave. Waves that have a higher amplitude carry more energy than a wave that you see more often, is what we want to know. So in this worksheet, there are 3 sheets, and that's what I just explained, that you're going to be showing the relationship between the frequency of the wave and the amount of energy that it carries versus the amplitude of the wave and the amount of energy it carries. And so on the first sheet, you're looking at frequency and energy, and the relationship between those two, frequency of a wave and its energy, is pretty straightforward. This symbol means proportional to. When we're talking about frequency and energy, you can use the equation frequency is proportional to energy. That means that for every 1 unit of frequency, remember the frequency is how many the counting of the oscillations. So for every 1 unit of frequency increases, the energy of the wave E also increases the same amount. For instance, if the frequency of a wave is 1 unit, then the energy of the wave will be 1 unit. If we increase the frequency of a wave by 1, the energy would also have to increase because they are proportional to each other. Therefore, you're going to take that information and complete the table and fill out the graph below. So if they're proportional to each other, when one increases, so does the other, then they're increasing at the same rate. So you're going to fill out the rest of the boxes. If frequency is 5, then obviously energy would have to be 5 units as well. I apologize, these are not smaller, just make them smaller. And then if frequency is 10, obviously energy will be 10 units as well. Make sure you get into the habit of using the units as it will relate to your assessment. So using proper units will be important for you. So after filling out this chart, I'm going to make some dots so that I can graph this information. I'm not going to complete the rest of it for you. You can complete it yourself. I've gone through the first steps with you. Remember, in order to make circles, you go to shapes. I'm looking to make circles. You can just find the circle here, or use this one here, and create a small circle over here. It doesn't need to be that big in size. Right now it's filled in with a gray. You want to fill it in with black so it looks like a dot. Select it again and hit Control Copy and Control Paste, 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 paste. You probably need, I would start at 5, which is where you started filling in. You don't have to do the lower units, they're just examples. Or you can start at 10 if it makes you more comfortable to use the counting by tens. It's up to you. You'll still get the same data if you start graphing here versus here or versus here. So I would need 1, 2, 3, 4, 5, 6 dots. 1, 2, 3, 4, 5, 6. Again, you can graph more and graph all of them. I'm going to start at 10. So when frequency is 10 down on the bottom, then energy is also 10, and this is where they meet. I will drag and drop that dot there, and then fill out the rest. Drag and drop your dots for the rest of the graph. You can also use a line once you're done and connect your dots. You start at 1 dot, and then you go to the next dot, and the next dot, and the next dot, and then when you're done touching all the dots, you click off of the line, and it'll create the line for you. Obviously, that's not a correct line. I was just showing you how to make one, but I'm going to click on the line and delete it. The next sheet, after you're finished with the relationship between frequency and energy, you want to look at the relationship between amplitude and energy. The relationship between amplitude of a wave and the wave's energy is a little bit more complicated, right? I'm going to attempt to draw it for you so you can see. Amplitude is how high a wave is, and then I'll double click there. That would be, let me get a medium. There would be a medium. Oh, that is a terrible line, right? There would be a medium here. So you're looking at the amplitude of the wave, and back here, you're looking at, sorry, I'm going backwards, but you'll be fine. You want to look at the frequency of the wave. Sorry, obviously the lines aren't all even, but you want to look at how many more oscillations you see. You're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be the frequency of a wave versus the amplitude, the height of the wave. So when you're talking about amplitude and energy, amplitude squared, the squaring of amplitude, whatever the amplitude is proportional to how much energy it is. So that means for every 1 unit of amplitude, as it increases, the energy of the wave increases by the square of that. For instance, if the amplitude of a wave is 1 unit, then the energy of the wave would be 1 squared, or 1 times 1. So the energy would still be 1. That's easy. But what happens when you increase the amplitude to 2 units? The energy of the wave would then be 2 squared, or 2 times 2. The energy increases to 4. So you're going to use that information and again repeat the steps from the frequency sheet. And here the formula is different, right? So when amplitude is 3, to find the energy in the in that specific wave, you would have to square what the amplitude is to get the output of energy. So if it's 3, amplitude is 3 units, then the energy would be 3 squared. And 3 squared should be, hopefully you said 9. And yes, you are correct. I'm just going to make that smaller so it fits nicer on there. So 9. And then so forth and so forth. Remember, you are squaring these. So once you fill in the rest of your chart, I'm not going to do any more because you get the hint by now. You're going to do the same thing. Go and make a few dots. Just make 1. Fill it in with black. Control copy. 1, 2, 3, 4, 5, 6. And now I have 6. And so when amplitude, which is on the x-axis, is 9, right here, then did I mess that up? No, amplitude is 3. I apologize. I was like, that's confusing. When amplitude is 3, and here, maybe it's best to start with the 1 because you can see it better because there's a 1 here. So when amplitude is 1, energy is 1. Oh, maybe not so much, but I would say because 0 is on the line, I would say 1, and 1 on energy would be close to the line, just not on the line. And then when amplitude is 2, energy would be 4. When amplitude is 2, energy would be 4. I would say this is about halfway to 10, so that's 5. I would just drop it just a little bit lower than that. And then when amplitude is 3, energy is 9, there's 3, and so just before the line of 10, I would put my dot there, and so forth and so forth. And again, you can always go here and look for a straight line. Once you click on that, you can click on the dots going up and it will connect them for you. All right, so there's that sheet. And then you're going to head over to the last one, page 3. They're numbered for you. You're going to look at the relationships that you saw in the graphing, right? How does frequency affect the wave's energy more or does amplitude? And you're going to explain your reasoning. Be sure you fill these out completely. You're going to see questions like this on your assessment. So it's good to have good practice. And you're going to answer the questions about the relationships that you saw. You're going to click on number 6, more or less, for the equations that you see here or the statements you see. And again, you're just responding to what happened in the graphs and the charts. So that's it for this lesson. I'll see you in the next one.